1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 5. Source, first generator to first node, first generator to second node. It's a matrix. So this is intensive research is going on universally, and I think my candidate also done some work also in this work, and people are doing probably in this area also. Sharing of generator, load sharing, and how much power is being sold by the network class. How to split it, or how to divide it. I think I use the word divide. Why? Because we are going to use the current only. Because current is the reason for producing the power. Now our optimization problem, I think I will next slide. So, what is the power distribution theorem? This actually how much of power shared by each source. Any network also, not only for MOS system, even you can took any DC network, ordinary resistive circuit and DC source. Any network, I have given the software also, it's a general software. You can use it for, I also demonstrate it. So it is applicable to node and a part of the network. Even part of the network also same, because it is from the basic concept only we established this theorem. Therefore, it is giving an answer for all the network, whether it is a part of the network or any type. Suppose you take a node, some 4 lines are entering, 6 lines are going out. So 4 into 6 matrix you can get from the first line to first out, second line, first line to second out. Understand? So this theorem helps us to find out the sharing of in-field with the outgoing in general. So this should be included in the circuit theory literature. It should be useful for researcher as well as the elementary theorem applicable to any network. Therefore, students, undergraduate students also should know. Later I will come to another point. Based on that, I have done one innovative technology. See, research development is different, technology development is different. Research development means you are taking a base paper and then you are going through the subject matter, and then further what you are going to do, and you are trying to prove that your approach is much more better than existing. That is your research and development. Whereas technology development means the outcome of research work is being implemented in a real time and it is becoming a technology. Once it is used by society, then it is a technology. So you take 2 or 3 technologies and you drive another technology practically and you improve it. It's called technology development. That is are going back and then all these things, right? Now you clear. So technology development is different. Research development, which is more important in our country. Technology development is very, very important today because many papers are coming up, many PhDs are coming up. So what? Whether it is going to be implemented in a real time? Few. Understand? So that's why what I suggested, people should realize the concept. Then if they work for, our students are excellent, I will tell you, because after running 35 years of service, then I think our students are excellent. Only thing is not let them to learn. I already told you what is the method of learning, realizing, and then all these points are very clear that they will be motivated. Right? Next slide. First point is private sectors are coming. That is why we are interested to divide the power injected to the network by each source. Because if the government has to pay for that, right? How much portion is going for the loss also we can calculate. Similarly, evaluating fair and transparent tariff in the integration. That's why the second part. Last point is very important when you are going for optimization. I already told you, even I think studying the basic work is by what is called coordination equations. I think you studied in the Kirchmeier. The basic work, whatever the soft computing technique and everything is coming up, finally they are going to compare the result with the conventional method, whether it is satisfying it or not. But of course, now today, people are using discrete data. I will come to that point also. I already told you, discrete data means You cannot have a model. Earlier what they have done, they are fixing it in a quadratic function or a cubic function. You know that in mathematics how to fit the curve. Knowing the data of, say, you are having a group of data, input and output, you can fix it in a quadratic equation or cubic equation. Least square curve fitting technique. Like those things you study in mathematics. Right? See, so I'm saying that these mathematics are very useful for modeling it. So, later I will tell you. But there, total injected power is taken as an independent variable. And how you are going to estimate the loss? The loss is depending upon the injected power. How it is correct? The injected power is having loss itself. Total power injected by each generated to the network is not a purely independent variable with respect to the loss. Because one portion is also loss. So if you are going to select that variable as an independent variable, as a design variable, normally in engineering they said it's a design variable, then it will not give a proper solution, correct solution. Therefore, this helps us to divide the entire injected power, how much is for the load, how much is for the loss, then you can take independent variable is the load sharing. Because current flowing to the network, it is only producing the power. And if you take current as independent variable, well and good, your atomy is a problem. Because even the current, what he said, when you are going to get the optimum value, what he said, the differential of independent variable. The objective function, differential of independent variable. But what in Kirchmeier and all the books they have already written, you can see that they take the entire power, P, not the power shared by the source in the load, individual load. So it will not give the correct answer, that you can also verify. These are all the points which I am going to give, which will be useful for doing research further. Right? And also when you are coming up, definitely this will be very helpful, the application of this theorem in your research also. I think this is actually many techniques you are presented, this coming up. Still, there is no strict derivation for the algorithm. Proportional algorithm they have done. What they have done proportional algorithm? I think see, suppose this is a node. There are 3 powers are entering. Loads are there. There are so many loads are there. L1, L2, L3, L4. They will calculate the contribution of P1 to L1 will be P1 by sum of all these. I equal to 1 to 3 into L1. This is the sharing of L by 1, P1. That means all the input powers are added, active powers are added. And ratio of the source power to the actual source power I. That means here I have taken 1 first. How much it charge the L1 multiplied by P1 divided by all. This is already explained in IEEE papers and people are using this for finding the sharing. So, and there is no strict derivation is there. And also the paper also they mentioned there is no strict derivation. But here we are going to present this derivation, how we are going to do that. Complex power theory. Here I have taken complex power, not the active power only. See, we are taking entire power for establishing this theorem based on the current sharing by basic Kirchhoff's current law. I think very simple, you can easily follow. The way we are taking all these things, we explain. Node voltage is, suppose this node voltage is actually how it is being established because of the charge flow through the admittance of each node. I think I next diagram I will give. Change in any admittance will change the current and it will switching over to next operating point. See the load admittance here, if you go to change any next diagram. and the voltage is also being changed. When the operating point being changed, the node voltage is also being changed as well as sharing of the current also being changed. So this is not only for the node, network also this is same concept, because the network also total current entering into the network is equal to the total current leaving from the network. And also within the network, inside the network, at a particular operating point, any node in the network, the Kirchhoff current law is valid. You cannot violate that. Am I correct? So this is actually by nature, because of charge balance. This cannot be eliminated. Suppose you find a solution which cannot satisfy this. Solution is correct or correct. In a real time operation, Kirchhoff's current law is valid at any node inside the network and even part of the network. Any statement against this? Anyone of you? Am I correct? So this concept is very useful for us. That's why the power division theorem is applicable to the node as well as to the network also.
The node is a part of the network.
Part of the network means you can take some clear part of the network, some infeeds are there, some outgoings are there, any network part of it. So we can apply theorem. Say n infeeds, m outgoing, from first infeed to first outgoing, first infeed to second outgoing. For which also you can apply this. Understand? I think that's why I said already. So this is the statement of the theorem. I think please go through it. It is very simple, but the result is enormous. Why? We use KCL. That's why I want to teach you to the students. The concept is very important with proper understanding and realization. If you do so, they will be motivated and they can do wonders. So this is actually just like that. I try to find out this. You see that m sources are there, n loads are there. What is the power shared by the source I with the jth load Sij is equal to the ratio of the source current, that is source current Ii, which source you are considering, to the ratio of total current. That's all. See that how much simple the algorithm. They use the graph theory and so many things they use. You can go and see all the papers. I think I published this paper in the International Journal and it's available in your CD. So see, reference is also given. I also given a literature survey also because I didn't like to waste my time to describe all the graph theory and everything for which the existing literature is there. You go through it. Okay? Those who are interested to do the research in this area. Now you can see that the load Soj is the total load given by the complex power equation. This is the statement of the theorem mathematically represented. Sij, ith source to jth load equal to, this is the jth load total power multiplied by Ia by Ia. That's why Ia is the total current injected. You can use V conjugate I will tell you. I understood. I think P minus JQ, when you are taking V conjugate I, P and Q are positive. When you are going to take P plus JQ, only the applications are there. But if you put a vector, V is there, I is normally lagging. Right? You can say V is theta V, I is theta I. You can put V conjugate I, you put Vi in the I minus theta. That is the difference between it. So, only thing is what we are going to, this is simple way. Complex power, I think if you are interested to restate Vi conjugate, not well and good. The only thing we are trying to equate the Q. That's all. In this case, lagging power factor Q is positive. Am I correct? In the case of leading power factor, Q is negative. that becomes plus. You are correct actually. Anything you can use. Okay, now next. I am very happy to hear about some persons are keenly following whatever. See, this is the node, whatever I have written here. Source 1, source 2, source 3, n sources. See, loads are there. See, you can ask the question, sir, in a network, this is a network. So how can you say this is only admittance only you are representing? Mutual is there. Am I correct? In a network, mutual is there. But whatever may be the case, this particular node which is going to face only one admittance. Admittance means opening. How much is open to receive the charges? The admittance is large, more charges, more current. Inside whatever may be the case, we are not calling about it. Finally, depending upon the admittance or impedance value. Impedance means low impedance means it will take more current. Okay? The representation. If you take this as reference, because finally return path is there. Return path definitely is there. Am I correct? You are saying that, sir, this is going to another node. I am not talking in the node. This is in reality what it is facing. Physically what the node is facing with respect to load at different points in the network. But here we have considered only node. Node means it is returning in negative, that means you are negative. Or you can say this ground entirely. So similarly in the network also, finally it is returning with a common point. That's why I said current entering to equal to sum of the current is equal to sum of leaving current. That concept is there. So anyhow, each facing admittance, the node charge cannot be retained in the node. Then it is a storing charge means it becomes a capacitor. Node cannot retain charge. Whatever comes, it is diverted. That's all. Right. Next slide. I think now it's a very simple explanation. Total admittance. This equation you can easily go through it. I need not explain. You can easily understand. Current in the jth load, everything is given. Multiplying 3 by with the node voltage, you will get. There, I can from the equation you can write like this, and you will get total complex power at the node SA, SB, and the IA. Therefore, you can directly using this equation. You can prove that. You can see that. Equation 4 can be written like this. You can ask a question, sir, what is the wrong in that? Initially itself you can write a VA into IA conjugate. VA into IOJ is the load of J. Am I correct? VA because voltage is the node voltage. Because the load is connected in the same node, so VA into IOJ is the load power. Simply take IA by IA, multiplied it. But I am going to start from here. You can ask a question, sir, why you multiplied with IA by IA? That's why from the basic principle I arrived this equation. Now you understood. Straight away I can write the SOJ power, that is jth load power is equal to node voltage into this current voltage. We can just multiply by IA by IA. Do not change anything at all. Why arrive this way? Because you should know the concept. That's why the previous equations. Now you can substitute here. You can get Sij equal to simply this, which is the statement of it. But simple approach, and it is valid for any network. I have given a general program, general network, any network or any power system. I will explain you the program also. Any doubt about this? Another topic is there. One example. This is and very you can say sensitive information is what is the contribution of source 1 to this load. physically what you are going to see that. People are now paying like this only. The actual deregulation is a DC network. Same thing is in the AC network also. The concept whatever they adopted in AC network because of this. That's why I see source 1, source 2 is here, load 3 and load 4 is here. You see that? What is the contribution of source 1 to node 3 load? I think because current is coming from source 3 to node 1 only. Therefore, physically what you said, sir, current is not flowing from source 1 to source 3. Therefore, it is not sharing the load. That's not correct. That's why I said it is sharing the load. That's called the back power. Without this source, what happens? This potential will not be available because of some charges here. That's why it is trying to retaining this. It sends current this side because of more charges coming from. So the excess charges coming from there only. Right? So don't think that this is not contributing power to the load. That's why the power is called back power. And people are working in this area, they are not trying to establish this back power, expression for back power. Now, because of KCL, we found out. This example is given as an example in your software given to you in the CD. So you can run and you can type permits and show it also. Right? Any doubt about this? So all are new informations which you are not so far received. See, the contribution of source 1 to 3 is 27.73 watts, simple network. But practically, when you are going to see that, that's why I said there are certain things which we do not know, but it is contributing by nature. So you try to identify that. But this concept can be implemented. Exact balance we will get for the entire network. So any part of the network sharing can be easily performed using this configuration. And if you are interested to use this for your optimization problem also, you can make use of these equations for finding the independent variable so that you can optimize. So the total, I think you can see a numerical because all of you also now very tired about this and then you can all available with your CD. So you can run it and you get this result. I am sure. Right. The loss also computed finally. All the element is I squared R loss. And you can verify with it. How you can verify? You know sources how much contribute for each load. You subtract from it. And the remaining add it, you can get the total loss how much you will get. And I squared R loss you can add it. And you can verify exactly. It's called power balance and the power set. Any doubt about these things? And next, I have to complete this and then finally I come for the practical demonstration. Concept of optimization. See, optimization probably what you actually the problem of optimization. Everybody is doing it. Tomorrow morning itself, you are doing it. We are trying to achieve our target. There are so many constraints, right? So our mind is doing. They are something fuzzy, and everything is fuzzy logic, and everything. Uncertainty is there. How you are going to do that? So these things are optimizations are normally everybody is doing day-to-day life. Even particularly ladies are doing in their house higher rate because they are going for cooking and how they are going to optimize based on certain financial constraints is there, then requirement constraints are there, and what is their target depending upon the target. So everybody is performing the optimization process. So in the optimization process, particularly in the power system problem, not only power system problem, any problem, it is a multi-objective optimization. We are not going to depending upon single objective. I think you studied about all this basic, but however I like to review it. Optimizing that, applying the best result under given circumstances, that's all. It varies from different problems, right? Gender. The optimizing defined process, finding the condition of giving maximum minimum, but of course, these are all basic study, you already studied. Mathematical or I think operational research, everything you study. You need not build the kind. It's a basic idea of optimization. And methods, I just while informing you those who are doing research, what are the methods available, that's why I given the information. And different kinds of optimization. Here it is very important, what are the optimization, what are the different programs are there. I already told you, whenever you are going to introduce the intelligence, it becomes smart. Similarly in our power system also, when you establish intelligence or introduce intelligence in a particular operation or power grid, then it is become a smart grid. I think now you know distribution, I think we were studied about distributed system, embedded system. So all are same. In all the cases when we are going to talk about grids, micro grids, they are going to introduce intelligence, then it becomes a smart grid. So in the optimization is actually a process where in which what we need is intelligence is required, and different persons, those who found out all these things are given for it. Right, this is a very basic concept already studied. This is for single function, how you are getting a minimum and maximum. You can reverse it, objective function, you will get a maximize it, you will get a minimum. That point I think you know. Right. Behavior constraint and the site constraint. So when you are going to teach this, how to introduce all these things to the students? See, our human system is a behavior. You can say like, suppose you are completing a task, you can say that boy, program some objective to do that. So you know, if you take 2 idlis, minimum, like that, minimum, that's the design variable, or maximum, 10 you can say. That's called the site constraints. Behavior constraint, if you take more than that, what will be the problem? Stomach ache. So like that you can interact with the students with how we are formulating or modeling the constraint. Why we are saying as a constraint? Why we are saying the objective function? Objective function is the completing the task to satisfy the constraint. But within that, suppose I said 2 idlis and 10. So within that they can consume anything. It is feasible. But even though it is feasible, which is highly suitable? Depends on, because cost is there. For more idlis means you have to spend more money. Am I correct? So definitely entering with the optimization process. That's why I said that day to day like we are doing optimization. Okay. Next. This is a new concept which I have already introduced. People are doing work here, and I think I am sure about it after coming out from the Raja. Some ME students worked out. They have shown some result. After that, they stopped. But this already you know, site constraints and behavior constraints. What is meant by free point? That means free point means any point inside the constraint region. Feasible, but it's a bound acceptable. That means just is acceptable. And here is that bound unacceptable because it is away from this. So these things are already you know. So that's why I said that how we are going to interact with the constrained surface. Constrained surface mathematically we are representing. Say even you are representing phase difference. What is the meaning of phase difference? You are saying that current lagging by 90 degrees in inductor. What is the meaning of it? Any one of them, please tell me. You are saying that current is lagging the voltage across the inductor by 90 degrees. What is the meaning of that? Physical meaning. What is the physical meaning? See, it is a mathematical representation, but something is happening inside that is being represented mathematically. I agree. Magnitude varies actually. What is the meaning? but you are not able to correct answer. You are correcting. See, the variation of the voltage is going on. Similarly, current variation is also going on. But current variation is lagging by 20 milliseconds. That's all. 90 degree means, sorry, 1 cycle how much? 50 cycle means 1 by 50, 20 milliseconds, 5 milliseconds. 90 degree means 5 milliseconds. Am I correct? So, since it is varying with 5 milliseconds, after the voltage reach max